Welcome back for the second part of the notes on rational and irrational numbers. In the last section, we converted fractions to decimals, decimals back to fractions. We looked at square roots and cube roots. And in this section, we're going to talk about estimating irrational numbers. Okay, so first off, we need to know exactly what an irrational number is. Well, a rational number is any number that can be written as a fraction. This means that an irrational number would just be any number that cannot be written as a fraction. In the last section, we only talked about perfect squares, so numbers like the square root of 25, where when you take the square root of 25, you get a whole number answer 5, because 5 times 5 is 25. Not every square root has a whole number answer. Okay, and sometimes we need to know about the value of that square root. So let's take a look at example 1, because we can kind of follow the steps to figure out exactly how we can estimate square roots that do not have perfect square answers. Okay, in our example, they give us the square root of 3. Okay, so we want to start, and I'm going to kind of ignore this whole section. I'm going to use the steps, but I'm going to draw a little bit larger for you on the right. So we have the square root of 3. And we want to find a square root that is smaller, that's a perfect square on the left side, and a square root that is larger, that's a perfect square on the right side. Okay, so I know that the square root of 1 is a perfect square, and it's really close to the square root of 3. And I also know that the square root of 4 is a perfect square, because 2 times 2 gives me 4, and that's really close to 3. Okay, so I know it's between those two square roots. So if I know it's between those two square roots, I also know that it's between their two perfect squares. So the square root of 1 is 1, because 1 times 1 gives me 1. And the square root of 4 is 2. So I know that the square root, let me erase that, of 3 is between the numbers 1 and 2. So it's some decimal, 1 point something. Okay? And we want to then kind of just start picking decimals and squaring them and see how close we can get to the square root of 3. So, for example, I'm going to pick a number closer to 2 because the square root of 3 is closer to the square root of 4 than it is to the square root of 1. So let's do like 1.7 and we square it, which means we take 1.7 and we multiply it by itself. So when we do 1.7 times 1.7, you get 2.89, which is really close to 3, but not quite 3. So let's do 1.8 and see if it's closer or further away. And when we do 1.8 times 1.8, we get 3.24. Okay, this number is 24 away from 3, or 0.24, 24 hundredths away. This one is 11 hundredths away from 3. So 1.7 is a little bit closer. So we say that the square root of 3 is approximately, and that's what this squiggly equal sign stands for, it's approximately 1.7. And we could pick 1.72 or 1.73 and see if we can get even closer and closer, but for now we're just going to stick to finding it to the closest tens place. Okay. They may ask us to take these square roots now and put them on a number line. Okay, so if I'm looking for where this falls, it falls between the numbers 1 and 2. And on my number line, I have all the tenths spots, starting at 1.4 all the way up to 2. And if we know it's about 1.7, it's 1.7 something, so it's anywhere in between 1.7 and 1.8 is approximately where it'll be, and we can just label it as the square root of 3. And that gives you an idea of about how much the value of the square root of 3 is. I'd like you to pause the video, take a few minutes, try the next two, resume the video, come back, and I will go over the other examples. So let's start with example 2, the square root of 21. I need to first look for perfect squares that are between the square root of 21 is between, the closest one that's smaller is the square root of 16. The closest one that's larger is the square root of 25. That means that the square root of 21 is somewhere between 4, because that's what the square root of 16 is, and 5, because that's the square root of 25 is. When you find the two perfect squares that it's between, it should always be two consecutive numbers. 2 and 3, 4 and 5, 8 and 9, 10 and 11. It should never be 4 and 7. Okay, so if you end up with that, that means there's another square root, perfect square that's closer that you missed. Okay, so I know that the square root of 21 is somewhere between 4 and 5. I look at 21, and 21's slightly closer to 25 than it is to 16. So it's probably in the middle somewhere. So I'll start with 4.6, and I will square 4.6, which is 21.16. It's a little too large, so I'll go back, and I'll do 4.5, and I'll see how close 4.5 squared is, and it's 20.25. This is 0.75 away, or 75 hundredths. This is 16 hundredths. This one is a little closer, so we say the square root 21 is approximately 4.6. Okay, and you start to kind of see the pattern, and it gets a little bit easier every time you do one. So let's take a look at the square root of 15. Let's find our two perfect squares, that the square root of 15 is between, including 9 and 16. The square root of 9 is 3. Square root of 16 is 4. So my answer is somewhere between 3 and 4. 15 is very close to 16, so I want to pick decimals that are really close to, but not quite 4. Okay, so I'm going to start with like 3.9, because that's very close. And I'm going to do 3.9 times 3.9, or 3.9 squared, to 15.21. A little bit larger than 15, so I'm going to go a little bit smaller. I'll do 3.8 squared, and I'll see which one is closer. So you do 3.8 multiplied by 3.8, and you get 14.44. This is 0.56 away from 15, up from the next number. This is 0.21 away from 15, so that's slightly closer. So we say the square root of 15 is approximately 3.9. Okay, this is a rough estimation. It is not an exact answer for these square roots. Since they're irrational, they don't have a perfect answer. Okay, they have a decimal that continues on infinitely, so all we can do is get as close as we can to give us a pretty accurate estimate for those numbers. Okay, I hope this makes a little bit of sense. As you do them, they get much, much easier. Okay, I hope you have the notes that go along with it. If you don't, go down and click the link for my Teacher Pay Teacher store. If you have any questions, please feel free to ask, leave a comment, do whatever you have to do.